Previously, we talked about how the magnitude, or the numerical portion of a measurement, contains digits that we are absolutely certain about, those that had markings on the tools that were surpassed, and a digit that is merely an estimate, one decimal place past the smallest markings of the tool. We also talked about how to determine, by examining the tool used in a measurement, how many decimal places can be legitimately reported in a measurement. In this video, we'll talk about how to look at a measurement that has been made and determine how many significant figures are present. This is important because when we use these measurements in calculations, the level of precision we can report, or how we round off our calculation answers, is based on the level of precision, the number of sig figs, in our measurements. In any given decimal place, there are 10 possible digits that might reside there, 0 through 9. The good news is 90% of those digits, that is 1 through 9, when present in a measurement are considered significant, so there's no question about those. That 10th digit though, the 0, it can serve one of two purposes. It can represent a measured quantity, and therefore would be significant, or it can serve as a placeholder, which would not be considered significant, in a measured sense at least. To determine whether or not the digit 0 is significant in a measurement, we must examine where the 0 is present, and some other features in the magnitude number itself. First, any and all zeros that are between non-zero digits are considered significant. I call these sandwich zeros. In the measurement 1025 meters, the 0 in the hundreds position is significant. In order for us to state with certainty how many tens of meters and estimate to the nearest whole meter, we must know with certainty how many hundreds of meters are present. Sandwich zeros are always significant. Sometimes you'll see measurements with magnitudes less than 1, where 0 will be the first digit or digits present. I call these leading zeros. Leading zeros are never significant in a measured sense. They exist either as placeholders or to ensure that the reader doesn't miss a decimal point. For instance, in the measurement 35 thousandths of a gram. Written in decimal form, it may look like this. The 0 that is in the tenths position is not certain, because we know that there is more than 0.1 of a gram. The measurement indicates there are 35 thousandths of a gram. It also is not estimated, because it is not the last digit in the measurement. Its importance is that the 0 is holding open the tenths place so that the digits 3 and 5 can represent the number of measured hundredths and thousandths of a gram. Other times, you may see a 0 as the only digit to the left of a decimal value, such as this measurement. In this case, the digit 0 does not represent a certain or estimated value. It is simply there as a convenient way to avoid missing the decimal point that is written there and misinterpreting the measurement as 25 liters instead of 25 hundredths of a liter. Leading zeros are never significant. So that leaves one other place for the digit 0 to show up, at the end of a number. I call these trailing zeros. Trailing zeros may or may not be considered significant from a measured standpoint, and the way we can tell the difference is for looking for one very specific feature, a visible decimal point. Put simply, if a decimal point is visible, then trailing zeros are significant. If a decimal point is understood, you know where it's supposed to be, but it's not actually present, then trailing zeros are not significant. Take these two measurements. Though they appear to be the same, the difference lies in the precision of each measurement. In the first one, there is no decimal point, so the trailing 0 in the ones place is a placeholder, not a measured digit, and therefore that makes the 5 the estimated digit. Hence, this measurement is only precise to the nearest 10 grams. The second measurement, by the simple presence of the expressed decimal point, indicates that the 0 in the ones place is in fact a measured value, an estimate in this case, making this measurement precise to the nearest whole gram. Numerically in a calculator, both numbers will work the same way, but the importance of using correct significant figures lies in how many digits you'll be able to retain when we use these measurements in calculations. To summarize, all non-zero digits in a measurement are always significant. The digit 0 is also significant if it's between two non-zero digits, a sandwich 0, or if it is a trailing 0 when a decimal point is visible somewhere in the measurement. The digit 0 is not significant if it is a leading zero, or if it is a trailing zero in a measurement where the decimal point is understood but not visibly expressed.